I just look back at the formulas, make sure you know how to use it, right? All right, ready? Right, so here we have a circuit. Here we have a circuit, we have three resistors, right? We have three resistors, two in series and one in parallel. One in parallel with those, right? If I connect it, you will see it. Right. So everything there, right? You'll see enough? So what I want you to do here now, draw the circuit of course. And let's see if we can find the total resistance and total current in that circuit. Find the total resistance and the total current in that circuit, right? And it's showing you all the values. right? These two resistors on top here and what's all here, right? So you got to work out those first, right? And then what happens? I'll change it after. Find the total resistance and then the total current in the circuit. Normal electrician become figure. Maybe. If not, just lock it. Right. So let's check out total resistance first, right? One thing I like to do is simplify the circuit. So now you will have one big resistor here and you'll have a next resistor on top in 9 volts, right? So here's 10 and here's now 20 ohms. Right? So total resistance will be 1 on R is equal to 1 on 20 plus 1 on 10. How much y'all got? 3 on 20. Yeah. So R is equal to 20 over 3 volts. Anybody got? 6.67, I think. Yeah. And then you're going to find current. What's the formula to find current, Leonardo? How we going to get current? We have resistance and we have voltage. But look back, you do the same thing last week. I is equal to what? Remember, Matthew, I is equal to what? P on R. Right? Let's use this circuit now. Let's use this circuit and see what they got. Let's use the ammeter and the total current is 1.35. Look at that, 1.35. So if we calculate it, it should be, where did the pen go? Right, if we calculate it, it'll be 9 over 20 on 3. Okay. There's 27 on 20, which is, as we have there, 1.35 ampere. Okay, if you look at what I did, I will have combined these two first. I found the total resistance to be 20 on top there, and when you look at those two in parallel, and the total is 20 on 3, and I use ISB on R. Right. What do we know about what do we know about current in parallel? How does it behave? Current in parallel what? They split up. Okay. So here's what I want to do now. Find the current. Find the current here. Let's call it I1. Find I1 there for now. Find current through the lower resistor. Find current through the lower resistor. Same formula. Same formula, right? Try to find current through the lower resistor there. What's the formula again? Lindsay, what we use to find current again? I is equal to P over R. So R is how much? F for that is this stuff. R is how much? How much is R? 10, right? What how much is V much? We know about voltage in parallel. You see? Voltage in parallel is the what? Same. What's the table? What they say about voltage in parallel? It's the same, right? So if your supply is 9, your supply on top here is 9. It means that the voltage across here is 9 and the voltage across here is 9. Okay? So use the formula and find I1. Right? How much you got? 9 over 10, 0.9. Right? Let's use this and see what we got. 0.9, correct. You okay with that? Charles, so what will be the current on top? I2 here. What do you think I2 will be? That's the one up here. No. total current is 1.35. And down here is 0.9. So how much is on top here? The total current here is 1.35. Current in parallel splits up, right? So if underneath is 0.9, then on top here is how much? Check it, cancel. How much you get? So what you would do about Leonardo? What you would do? Huh? Divide now. You only divide by 2 if the resistance was equal. What you had to do? It's your minus and shift minus. Yeah. So 1.35 minus 0.9. Right? Technically you divide by 2. But that's not what I want to do, right? Minus the 1.35 and the 9. So you will see this value here is 0.45. That's okay. So the current on top is equal to the current underneath. Online, are you okay with that? You have got those values, Nuria, Annalie. Yeah, you all got those values. All right, nice. Right, so again, what's the rules? V is equal to IR. Resistance in parallel and resistance in series, you know what to do. Current in series is the same, parallel splits up. Okay, just let's remember those rules. Let's go again. Let's try next circuit there. Shots. Okay, let's leave some of the parts. All right, so let me put one here instead. One here. And one here. We might want to a little bit more challenging. I told you. Put one more here. Right? Right, my dream. I'll give you. You want something more challenging? I'll give you. But if you go once, I'll get them. Right up our battery here. And I'll put a switch here. Right? Show it in the meantime. Right. So right, you take that out. Right? Have fun. Right? So I want you to find total resistance to total current. Total resistance, total Current, those who online, you'll message, right? I want to see your answers. Annalie, especially you, Anya. Anya and Vinny. I'll see your answers, right? Dante. Dante. Right? Let's look at an idea, right? Ashton, how I can make that circuit simpler? It's not all series and all parallel, right? So how to make it simpler? There must be a way to convert it to all series or all parallel. How are we doing that? What's that? The way to So you always had to figure out, do I take the two series and turn them into parallel? Or do I take the two parallel and make it as one in series? That's what you had to figure out. So you want to find a way to simplify that circuit, right? Could you work with these two? Those two are in what? Series. So what you will do? Add them up. So you'll get 20, right? What about these two here? Those are in what? Parallel. But when you work them out and you get one resistor, it'll be in series or in parallel with the others. When you work out these two, right? And they become one resistor. Would it be in series or in parallel with the others? Series. Very good. That's it. So the way Lindsay to work it out is to take it two in parallel and put them in series with the others. Okay? So you always have to find a way to simplify your circuit, right? Go ahead. Finish already? What you can do is find the current or it's split them up. And the voltage. Yeah, yes. Take up question number. Right, so when you work out these two here, you got 1 on R is 1 on 10 plus 1 on 10 plus 2 on 10, so I got 5. You got up? 5? Yeah? Brianna, you got 5? No? Remember to flip it over, right? You got 5? But you got 2 on 10? Yeah, flip it over. If you're using this formula, flip it over, right? Online send anything? Nope, no answers from online. No. No, you're going to send an answer. Annalie to have evening. Oh, wait, no. If you send something, man. Right, baby, hello, mistake there. You can check back in total. So, in this question here, what's the total distance? 25, right? 20 plus 5. Are you okay with that? Let's see, you okay with that? So, what's the total current? V divided by I. I was waiting on Charles. How about Charles? How much you gonna pay? Total current. Work it out. Work it out and tell me how much you got for your total current. And then Machu, I'm going to ask you, what is the current when it's split up here and here? I want to answer that, right? Right, find the total current, you know how to find I is V over R, right? You got all that? How much you got? How much? 0.36. But let's get up, 0.36. Let's see what you got here. 0.36. Right, so all we have to do is divide 9 by R. 9 divided by 25. Okay? Much you get up? 0.36. Right, Machu to help out here now, Machu, when the current split up here and here, how much you will get? Huh? 0.9. Think about it, the total 0.36. So how will it split up? And the resistance is same. Look at the resistance. Are they the same? So the current will split up equally, right? So one will be 0.18, the next will be 0.1. Let's split up even. Are you okay with that? Let's go again. Right, I don't want to mash up this circuit here, right? Here we are. Please send some answers. You want to be right, so I don't want to mash up this, but I'm going to take this. I will dump that. I'll take this and dump that. I'll take this and dump that. I will take a wire, put the wire here. I will take this one here, pull it back in. See that? And I'll take a next resistor here. And a next resistor here. I'll take a wire, take this wire and put it here. Could I put it here? No, kind of connection to make. Wait, tell them where they're in. I'll do that. Right. Using a linear matching. Total resistance, total current. Right? While you're working, I'm gonna pick on Charles. Charles, these two are in what? Parallel, these two are in what? Parallel, right? But look at this here. What you can see about these two, this, when you work out this and when you work out this, those two are in what? Series, right? When you work out this, you'll get one resistor here. When you work out this, you'll get one resistor there. So technically, those two are in. Right? You're saying find total resistance, total current. Finish? Finish already? Yes, total resistance, total current. You should have this one. Should okay, I like some of you all getting it, right? But what would be real nice after you do it is I tell them it's in series. So one option is this, which you do have to do. One option is this, right? Here's 5 and here's 5. That's one option. And then what that means is that the answer 10, right? Or you can just tell them this. After you work out this and this, you can say total resistance is 5 plus 5 after. Right? Some of you all skip that step and went straight to find current, which is V on R, which is 9 on 10, right? Some of you all skip that step, right? Please do skip that step. Right? Sometimes you have to simplify the circuit to work it out, right? I just help you out there. Hold it, again. Quickly again, I'm not sure. All right, go on. What is happening again? The loss is clear. Wait, what is happening? Anyways, going this again. No, you have to shoot on your that. Alright, no, you didn't know anything. Alright, are you okay with that? So that's basically how you work on the questions, right? But please show them how you got the pass in between, right? Let's try a pass paper now. Try this one here. I don't know what year it is, but it's a past paper, right? Each one has 3. So you have to figure out how to simplify this circuit. Question, these 2 are in one. Those 2 are parallel. You're seeing that? Yeah. Seeing that those 2 parallel? So combine them into one and make it look like that, right? So it becomes easier. Matthew is seeing that those 2 parallel. How you know that, Matthew? How you know that those 2 parallel? What do you think? Tell me. How you know that those 2 parallel? What? Matthew here's why, right, Matthew? When the current reaches here, when the current reaches this junction, it gets split up here and here. And current splits up parallel. Okay? And then when the current reaches here, it will join back again. So the same current flowing here and here. So those 2 in series, these 2 in parallel. Right? Take your time, simplify your circuit. I like to do this. You should as well. Simplify your circuit and then find whatever they are. Okay? Okay. Yeah, Annalie, the last one was 10 and 0.9, sorry. Maybe I'm not done already. So when you look out, part field R2. Right, let's just check out some of your values. So here's 3, here's 3, 3. Right, let's work it out in parallel. So 1 on R is 1 on 3 plus 1 on 3, which is 2 on 3. So when you flip it over, you'll end up with 3 on 2. Here's 3 and here's 3. So the total resistance is 3 plus 3 plus 3 on 2, 7.5. Yeah. Next one, current. I is equal to V on R. So that is 12 over. What is that? 1 point. Right, I'm giving you some time to figure out the last one. R2. What will happen at R2? Look at the circuit. Current flowing, right? And when it reaches here, how long did? They'll split up, right? And each of those resistors are how much? Each of the resistors R2 and R3 are how much? So they're equal. Think about it and tell me what you get for R2. What current is in R2? Is it not C and R2 is here, right? This one is R2. You know what's in my book, so you didn't watch it again. So which one? All. I follow what I did. But take all part two. Go ahead. We have some time. Right? What we have to. Oh, Rima. How much you get? You don't know how to? Well, think about it. What's the total current in this circuit? What's the total current in this circuit then? $1.6, right? So when that 1.6 reaches at that junction, what happened? How it just splits up? Each have the same resistance. Half. Right? It'll split up half, right? Good. So therefore, what's the current flowing in? 0.8. Nice. Right, good. I know what they asked for, and they asked for voltage. And they asked for voltage. So one click on it. Dante. They asked for voltage. So you find voltage again, V is equal to current by resistance. And we know the current. Current is 0.8 and the resistance is just for R2 alone. 3, right? So the answer is 2.4. You sorted it, Ashton. Sorted it. So I found the current and then I found the voltage. Is there next week? Can I have done differently? Huh? Tell me now, what you did. Huh? That's good about some magic. Yes. The next option is to find the voltage here and find the voltage here. And then minus it from 12. That's what I do. Again, it's important we understand series, resistance in series and parallel and current in series and parallel and voltage. All right. So that's more to do next year we do our next set. All right. Some of you are going to put up your own group yet. And not yes, yes. Okay. I want to give you one for homework, but I will add it first and then I'll put the homework, right? Dante, do I have your number? Yes. All right. So I'll give you our next one for homework, right? I'll send it to you.